A Brief History of Time by Stephen Hawking. Chapter 1, Part 2. Nearly a century passed before the idea of Copernicus was taken seriously. Then two astronomers, German Johannes Kepler and Italian Galileo Galilei, started publicly to support the Copernican theory, despite the fact that its orbit predicted did not quite match the ones observed. The death blow to the Aristotelian theory came in 1609. In that year, Galileo started observing the night sky with a telescope, which had just been discovered. When he looked at the planet Jupiter, Galileo found that it was accompanied by several small satellites or moons that orbited around it. This implied that everything did not have to orbit directly around the Earth, as Aristotle and Ptolemy had thought. It was of course still possible to believe that the Earth was stationary at the center of the universe and that the moons of the Jupiter moved on extremely complicated paths that looked like it was moving around the orbits of Jupiter. However, Copernicus' theory was much simpler. At that same time, Johannes Kepler had modified Copernicus' theory, suggesting that the planets moved not in circles but in ellipses. An ellipse is an elongated circle. The predictions are now finally matching the observations. As per Kepler was concerned, elliptical orbits were merely an ad hoc hypothesis and a rather repugnant one because eclipses were clearly less perfect than circles. Having discovered almost by accident that orbits fit the observations well, he could not reconcile them with his idea that the planets were made to orbit the sun by magnetic forces. An explanation was provided only much later in 1687 when Sir Isaac Newton published his Philosophiae Naturalis Principia Mathematica, probably the most important single work ever been published in physical science. In it, Newton not only put forward the theory of how bodies move in space, but he also developed the complicated mathematics needed to analyze those motions. In addition, Newton postulated a law of universal gravitation according to which each body in the universe attracted towards every other body by a force that was stronger the more the massive the body and the closer they were to each other. It was this same force that caused objects to fall to the ground. The story that Newton was inspired by an apple hitting his head is almost certainly apocryphal. All Newton himself ever said that the idea of gravity came to him as he sat in a comparatively mood was occasioned by a fall of an apple. Newton went on to show that according to his law, gravity caused the moon to move in elliptical orbits around the earth and caused the earth and the planets to follow elliptical paths around the sun. The Copernican model got rid of Ptolemy's celestial spheres, and with them the idea that the universe had a natural boundary, since fixed stars did not appear to change their positions apart from rotation across the sky caused the earth spinning on its axis. It became natural to suppose that the fixed stars were objects like our sun, but very much further away. Newton realized that according to the theory of gravity, the stars should attract each other, so it seemed that they could not remain in essential motionless. Would they not fall together at the same point? In a letter in 1691 to Richard Bentley, another leading thinker of his day, Newton argued that this would indeed happen if there were only a finite number of stars distributed over a finite region of space. But he reasoned that if, on the other hand, there were infinite number of stars distributed more or less uniformly over infinite space, this would not happen, because there would not be any central point for them to fall to. The argument is an instance to the pitfalls that you can encounter in talking about infinity. In an infinity universe, every point can be regarded as the center because every point has an infinite number of stars on each side of it. Correct approach, it was realized only much later to consider the infinite situation in which the stars all fall in one each other. Then to ask how things change if one adds more stars roughly ununiformly distributed outside this region. According to Newton's law, the extra stars would make no difference at all to the original ones on average, so the stars would fall in just as fast. We can add as many stars as we like, but they will still always collapse on themselves. We now know that it's impossible to have an infinite static model of the universe in which gravity is always attractive. It is an interesting reflection on the general climate of thoughts before the 20th century that no one had suggested that the universe was expanding or contracting. It was generally accepted that either the universe had existed forever in an unchanging state, or that it had been created at a finite time in the past, or more or less as with the comfort that they found in the thoughts have been in today. In this part, this may have been due to the people's tendency to believe in eternal truth, as well as the comfort they would found in thoughts that even though they may grow old and die, the universe is eternal and unchanging.